When you are managing critical, high-stakes industrial assets, you simply cannot wait for a remote cloud server to return an answer. On the floor, everything looks fine. The equipment spins exactly at its rated speed, completing its daily cycles without a single warning light. Then, in a single violent instant, an internal shaft binds, the heavy metal casing fractures, and the entire machine tears itself apart before your eyes. The standard industry response is to throw machine learning at the problem. But machine learning requires massive datasets of historical failures to recognize a pattern, data you likely don't have for this specific piece of equipment. Even if you had the data, sending raw telemetry from critical infrastructure or defense contractors to an external cloud API is a severe security liability. For heavy industrial operations, traditional AI is a dead end. It cannot reliably predict rare events, and it exposes your critical data. This interface shows a typical SCADA dashboard right before a catastrophic failure. Every indicator is green, flatlining. We call this the green dashboard fallacy. This animation shows how traditional monitors work. Vibration and thermal sensors are amplitude-based. They watch for a signal to get louder or hotter, and when it crosses a red line, they fire an alarm. By the time a bearing generates enough friction to trigger that amplitude alarm, the metal is already scoring. The physical damage is already irreversible. You aren't getting an early warning. You're getting an automated autopsy report. To find the failure before the damage starts, we have to look past the volume of the signal and measure its structural health. A healthy mechanical system produces a signal with fluid elasticity, but as components degrade, the wave becomes rigid and constrained. Notice the amplitude hasn't changed at all. Standard sensors still assume everything is fine. We measure this structural decay using deterministic physics. There is no probability score here, and no guessing based on training data. The physics of mechanical degradation are universal. By tracking the loss of signal elasticity, we can detect the exact moment a machine begins to fail, giving you weeks of lead time before your dashboard ever changes color. Applying this physics engine in the real world presents a massive roadblock. Industrial sensors trap their telemetry inside proprietary binary files that routinely crash standard analysis tools. This is the FSME Data Ingestion Desktop Client. It's a standalone, offline utility that unpacks complex formats without requiring you to write custom scripts or install Python. Looking at the conversion log here, it parses multi-gigabyte files channel by channel. This means you can process massive HDF5 or TDMS files on a standard laptop without exhausting the system's memory. The software explicitly enforces a uniform time grid. If a sensor drops offline for 5 seconds, the client preserves that gap. If you treat a missing gap as a continuous signal, any physics engine will see a sudden jump and flag a false anomaly. In this inspection log, the chaotic binary data is flattened into a perfect analysis-ready format. Every output file receives a cryptographic hash to establish a strict chain of custody. The ingestion client turns an unusable hard drive of sensor telemetry into mathematically sound evidence ready for the physics engine. The entire analysis process takes place on local, air-gapped hardware. There is zero cloud connectivity, no API calls. No data ever exits the secure processing environment. The deterministic engine has been rigorously benchmarked against NASA CMAPS and ESA public telemetry, successfully detecting pre-failure signatures across entirely different physical domains. You maintain your strict air-gapped security protocols while gaining access to the most precise mechanical degradation analysis available. To prove this works on your specific hardware, we offer a single asset viability assessment. It is priced to fit on a corporate credit card, allowing you to bypass enterprise procurement friction entirely. You securely transfer raw telemetry from a past failure event. We process it offline and map exactly when the structural elasticity began to decay. If the math cannot prove we would have caught the failure before your standard dashboard alarmed, your fee is automatically refunded. Stop waiting for a machine to tear itself apart to find out you have a problem. True predictive integrity starts with deterministic physics. Visit fslogic.ca.